All right, number 6, we want to use the definition m tan is the limit of x goes to a f of x minus f of a over x minus a to find the slope of the tangent line to the graph of f at p. We're going to determine the equation of the tangent line at p, and we're going to plot the graph of the tangent line. So the first thing we want to do is find the slope of the tangent line. So number 6. Number 6. Our function f of x is equal to 3 divided by x. So we're going to find m tan, slope of the tangent line, by taking the limit as x goes to a of f of x, which will be 3 over x, minus f of a, which will be 3 over a, all divided by x minus a. Alright, so the problem here is we have fraction in the top and the bottom. The way I like to handle these is just multiply the numerator and denominator by the common denominator, and that will be x times a. So I'm going to multiply top and bottom by x times a. In doing so, the x times a, when I multiply, because you got to distribute to both terms, when you multiply the x times a here, it will cancel out the x, leaving you with a 3a. So that will give you 3a, and get rid of that fraction. When you multiply the xa times this term, the a cancels, leaving you with a minus 3x. And then you have the x minus a times the xa, which I will not distribute that. In the numerator, both of these terms have 3 in them, but the idea is I'm trying to cancel out this term. As x goes to a, this term is going to get close to 0, and so I'm looking to cancel out this term. So looking ahead, I want to factor out a negative 3 so that this expression will be equal to this expression. So if we factor out a negative 3, this negative term will become positive, so I'm going to put the positive x out front. Factoring out a negative 3 will make that a negative a, change the sign, and then leaving me with the x minus a on the bottom and our xa term here. So the x minus a will cancel out, leaving me with the limit as x goes to a of negative 3 divided by x times a. Now at this point, if we use direct substitution and plug in a for x, that will give us a negative 3 over a squared. So this will give us the function for the slope of our tangent line. We want to use the point P at this point to get the slope. So it says find the slope of the tangent line at point P. So at this point, we're going to plug in the x value of 4 for the a value. So negative 3 over, so now we have 4 squared. That will give us negative 3 over 16. So this would be our slope, negative 3 over 16. So now we want to determine the equation of the tangent line at P. Use a new sheet. So now that we have our slope, negative 3 over 16, we're going to write our slope-intercept form, y equals mx plus v. We're using the point 4 and 3/4. This is our x and our y. So I'm going to plug those into slope-intercept form. I got the slope, I got an x and y. We're going to find out what v is. So 3/4 equals a negative 3/16 times our x value of 4 plus b. So this will give me 3/4. If I do 4 divided by 16, because that's what's happening, you can multiply or you can reduce, and reducing is going to help. That will divide out and give me 3/4 plus b. And if I add 3/4 to both sides, that will give me 6 divided by 4 equals b. So now that I know b, I can come back and say, okay, my full equation is y equals the slope negative 3/16 x, and then it'll be plus 6/4. So this will be the equation of our tangent line at the point P. Y equals negative 3/16 x plus 6/4. Alright, and then part 3, it says plot the graph of f and the tangent line at P. So if we look at our graphs, we want to plot those points. So if we notice our slope is negative, so I'm looking for a red line to be going down from left to right. That one doesn't match. This one is horizontal. This one is the right direction. This one is not. So just strictly based on the slope of our tangent line, we can get that C would be our correct graph. It's just kind of hard to see all that.